Balancing is the act of making the effective mass of rotating components statically and dynamically equal by its rotating axis. The condition of unbalance of a rotating body may be classified as static and dynamic unbalance. In the case of dynamic unbalance, the unbalance can be in different axial planes. As a result, while the shaft rotating, the two unbalanced forces form a couple, which will rock the axis of rotation and cause the undesirable vibrations. We have two types of balance. A shaft with masses mounted on it can be statically and dynamically balanced. If it's statically balanced, it will stay in any angular position without rotating. If it's dynamically balanced, it can be rotated.
Before doing the product, calculation is needed. Firstly, list out all the data given and draw the free body diagram. Let's take 1 as a reference. Find R and theta value for stick 4 by using equation of equilibrium of moments. Both horizontal and vertical components are calculated to get cos and sine values since tangent theta equal to sine over cos. In this case, theta is negative. It's dropped at 4 quadrants, so the actual value of theta 4 is 360 degree minus theta 4 without negative sign. Then R4 and theta 4 is found. Next, repeat the step above by applying equilibrium of force as shown in the slide. The theta is positive. It falls at third quadrant, so 180 degrees added to get actual theta value. Finally, all the R and theta value are found.
This model has for stick 2 and 3, the data for angle and eraser distance are given, while for another 2 stick, which is stick 1 and stick 4, the angle is per calculated, but the distance is a bit different from calculation. So, per stick, the angle is 219, the distance is 10 mm. For stick number 2, the angle is 10, and the angle for stick number 3 is 135. For the stick 2 and 3, the distance between the shaft and eraser are same, 35 mm. For the stick 4 is mounted with the angle is 285 and eraser distance is 10 mm. So, this model are said to be balanced since it is not affected by centrifugal force when rotating.
Hello, my name is Muhammad Arifi. There are two types of balancing. First, static balancing, and second, dynamic balancing. The purpose of the experiment is to demonstrate the static balancing and dynamic balancing. The objective of this experiment is to apply the static balancing and dynamic balancing to this shaft to minimize their vibration.
Hello, my name is Kelvin. I would like to brief about the calculation part. In this experiment, we have to find out the angle and radius of countermass A and also countermass B. The method that we use are called a graphical method. First, we draw a movement diagram by selecting the countermass A as the reference plane so that we can find out the angle and radius of countermass B. Then we draw a force diagram so that we can find the angle and radius of countermass A.
Hello, I'm Yiling and I will brief on the physical model. These are parameters of physical model. Now I'm going to talk about steps to produce physical model.
Step 1. Weight the eraser. The weight of eraser is 8.85 grams. Step 2. The eraser placed on the red wooden stick is according to the radius given and the radius of the orange wooden stick is according to the calculation. Step 3 is position all the wooden sticks with their angles. Step 4 is distance between each wooden stick. The distance is 15 mm. Step 5. The shaft is placed on the supports to show the system are statically and dynamically balanced.
The process of providing the second mass in order to counteract the effect of the centrifugal force of the first mass is called balancing of rotating masses. The balancing of rotating bodies is important to avoid vibration. This video was prepared on how to obtain our system in balance. As for the objectives is to become familiar with a simple, useful technique for dynamic balancing that can be used in the field and to recognize its benefits.
At first, calculation is made by using analytic method. To get the value of RC1, theta C1, RC2, and theta C2. The second method to get the value as mentioned before, which is RC1, theta C1, RC2, and theta C2, we can use the graphical method. This calculation was made to apply in the system of rotating mass for the test of balancing. This is the time-lapse process of making the system balancing of rotating mass. For the detailed information of procedure, please refer the lab report prepared by us. In this scene, we are spinning the shaft 3 times for the test of balancing system, as follow the instruction in the lab report.
Okay, kau buat lagi banyak video je kan. Mesti tak sama je sekali lagi.
Memanglah tak sama.
Bukan mesti tak sama je.
Tu dynamic balancing buat static balancing tak.
Okay, kau buat sekali lagi. 12.
Dah.
Dah.
Lulus.